Hey everyone, I'm just making this video because we couldn't meet today and I was going to show off what I have, so I'm just doing this video instead, just to keep you in the loop. This week it's mostly good news for me. I've worked on a bunch of stuff which I'm going to go over in a second, but yeah, mostly good news, so I'm quite happy with this week. So what I've done this week, first thing I've done is optimizations to the project. So generally I sped it up from about 5 FPS in the editor to 15 FPS, which is pretty good improvement. Mainly this was done through changing JSON serialization to BSON, so instead of using text-based we used binary-based serialization. Compiler optimizations with IL2CPP, and there were some very small things you can do in Unity to speed up the build process as well, so I've done those. One of the big ones was the way data from ROS was being copied across into the main thread, so I sped that up using a block buffer copy instead of actually just assigning it. I also looked at the profile that comes with Unity. It's a very useful tool, and it said that garbage collection was, through the roof. So there was huge latency on startup because of this massive 500 megabyte byte buffer allocation. And I've routed that out. I've routed out most GC calls, so yeah, runs a lot faster. Finally, Nick has wrote a custom WebSocket for this, which uses message pack. So apparently it's a lot faster, and this will basically allow us to skip the whole process of receiving the data, transforming that data, and then showing it back on the GPU. So with that in mind, that's what I'm going to be looking at in terms of optimizations in the future, is implementing this thing that Nick's made so we can get messages sent even faster. The second thing is the actual visualization. So previously, visualization on the HoloLens 2 in this project was quite tricky because ROS Sharp didn't work. Now it works. We can actually focus on testing and adapting that visualization to work on the headset. So just ignore that noise, that's a plane flying over my house. So after some jiggery pokery, we've now got this working, which is great news, right? So the HoloLens 2 visualization actually works on the headset itself, so it's not projecting it from the desktop. All the data is being processed on the HoloLens, which is brilliant because it means we can set up our ROS server somewhere, send the data over to the headset, and the headset will do the rest. It will transform that data and it will render that data, which is great. The headset now processes these points rather than remoting. So as I just said, ROS sends the data and the HoloLens itself transforms it and renders it. Now as a result, it does run a bit slower than the editor, mainly just because the architecture of the HoloLens 2 isn't as good as a desktop machine, which is as expected. But hopefully with those optimizations that I talked about, we should be able to get this running a bit faster. So with that in mind, this is what we had 2 weeks ago. So it's just my living room. And as you can see, it's just logging out that there has been some point cloud messages being sent. So you can see how slow these are compared to the editor. So it's actually just sending these, and it's just that number you see increasing is the sequence number of the frame. So basically that's just confirming that we are getting data sent across. This is what I made this week. So I took the visualization and I plugged it into this. Again, it's my living room. And you can see that it is updating. It's not updating very fast. As I said, it does run a bit slower on the HoloLens 2. But we can see some kind of point clouds, and we are rendering those directly on the HoloLens itself, which is great news. And yeah, it's pretty cool. I'm quite happy with it. Just need to focus on speeding it up now. And you can see Nick there because I'm playing this from a bag file. So yeah, that's the visualization stuff. It works on the headset. I'm very happy with it. The third thing is the Azure Connect, which I got in the week. So I set up these connects and managed to get them sending data via ROS. So it uses the Azure Connect ROS driver from Microsoft themselves. I have verified that it is sending that data with RViz, and I tried getting the visualization project to run with the data published via the driver, but I wasn't actually getting anything rendered. I think the reason for this is that the point cloud data that it sends, the Connect sends, is slightly different to what is in the project. So it uses a 32 byte stride instead of 20, for example, and colors are formatted differently. So I'm going to look at, in the future, the next steps is looking at getting real-time data streaming rather than just playing through a bag file in the current project. So I might have to change the code a bit to make it work for these particular types of frames, but yeah, I'm quite happy with it. I got it working with Ross, and yeah, I'll show you a demo of that. So let me just close out this presentation and go to RViz. So as you can see, Connect sensor is here on my desktop. You can actually see you can see this presentation here, but and you can see my hand. If I wave, there we go. You can see me waving, and you can see the depth and stuff. You can see my door there, and oh geez, and the stairs over here. So that's where we're at. I mean, this is just being published to this topic here, points to, but we actually have this Connect publishing data through Ross, which is great because now we can use it in the system. Just have to get that working. And on that note, that's it really. That's everything I've done this week. So optimizations, getting the visualization working, and finally having a look at these connects, getting them working with the with Ross. But I'm going to look at getting this data working with the visualization later. Thank you.